Welcome to this presentation on graduate study in biomedical imaging at Case Western Reserve University. I am David Wilson, the Robert Herbold Professor of Biomedical Engineering at Case. I'm going to tell you about our exciting program in imaging. I will give you a little bit of our storied history. This will include Nobel Prizes, imaging firsts, and famous alumni. I will highlight just some of our excellent research programs. I will then introduce you to individual faculty members with whom you might work. I hope to convey to you why I think our program is so special. I will end with some next steps for you to become a graduate student in our department.
I wanted to show you some of my favorite highlights from downtown Cleveland. So Cleveland is actually a small, big city. And so by that I mean it has many amenities that are found in a big city. It has an excellent theater district, all the major professional sports teams. It has some interesting museums like the Rock and Roll Hall of Fame. And all of these amenities are relatively affordable and very easily accessible. So I have season tickets to the Cavs and to the Playhouse Square Broadway show series. And all of this is within about a 20-minute drive of my home. So I want to point out that you do not have to be a BME undergrad in order to do biomedical imaging. Successful BME PhD students have come from physics, electrical engineering, computer science, chemistry, and so on. And even our BME faculty have PhDs in physics and electrical engineering and other disciplines. I want to point out that BME PhD students receive tuition, stipend, and travel to conferences. In case you didn't get it, BME imaging is a big tent, allowing people from other disciplines to. So Case is very well known for a remarkable invention called MR fingerprinting. This technique turns MR imaging into a highly computational method. For the first time, we do not simply get brightness on the screen. Instead, we get color-coded maps of the parameters such as T1 and T2. And these describe interactions of hydrogen atoms with the molecular environment. So here you see results from our newest professor, Dan Mall. She is creating reproducible quantitative MR fingerprinting and applying it to epilepsy. Machine and deep learning is a new, really big deal in biomedical imaging. So here you see results from Satish Viswanath. He's using machine learning to detect and stage colorectal cancer. I am using deep learning to identify coronary artery lesions and intravascular OCT images. Among other things, Dr. Matabushi's team is using image analytics and machine learning for detection and staging of breast cancer. Here is an analysis of H&E histology images. On the left, we see a mouse CT using a blood pool agent designed by Stathis. On the right is cardiac imaging, which is done by several of us. Dr. Flask has developed a new MR imaging approach to characterize cystic fibrosis in the lung. This is very useful for evaluating new drugs. Several Case investigators are developing new nanoparticles for imaging and therapy. Here is a new design developed by Dr. Karanopoulos for targeted immunotherapy of cancer. This is a very hot new area in cancer therapy. Dr. Music made an anti-cancer drug radioactive so that he can map its distribution in the body. The idea here is to provide a microdose of the drug to determine if it gets to the tumor. As it must get to the tumor in order to have an effect, this provides a means of determining a personalized medicine. Dr. Exner has developed a whole new way to do ultrasound imaging. She created nanobubbles, which give very bright echoes in ultrasound. In addition, since they are quite small, they can extravasate from a blood vessel, accumulate in a tumor, and make cancer very easy to see. So here are some results from advanced optical imaging technologies. On the bottom is a developing mouse heart imaged with a very fast OCT system. This is the work of our resident OCT expert, Dr. Rollins. And on the top is a very high resolution 3D movie through a rat ganglion using light sheet microscopy. Dr. Jenkins is developing technologies to map neurons in the ganglia, a network which is very little understood. Dr. Jenkins and I are developing a new method called Muse microscopy. Dr. Griswold is developing HoloLens for education and for surgical guidance. This is really super cool, allowing interactive visualizations that you can basically, as shown here. So Drs. Brown and Martins of the physics department have created complex models of magnets and MR systems so as to enable optimization of MR imaging. Dr. Rollins is using OCT imaging to measure strain in the cornea in the eye. And finally, I've developed a new 3D ultrasound system for obtaining the first ever images of the ciliary body in the eye. This structure is important to the study of glaucoma. So these are just a few examples that I was able to put together quickly. And I have to apologize for because many projects created by my colleague, I was unable to show those. So we have a proud history of imaging at Case. This is a whole body X-ray from 1896. 3 months after the discovery of X-rays by Röntgen, Professor Miller posed and Mrs. Miller operated the apparatus. This was the first X-ray imaging in the United States. Here's Paul Lauterbur receiving the Nobel Prize for MR imaging. He's a Case graduate. Here depicts the Michelson-Morley experiment, which got a Nobel Prize in 1907. This experiment is actually the foundation of present-day OCT imaging. These are just some of the many firsts. We have one of the first clinical CT systems and the very first CT guided biopsy. That was in the 70s. We created the Case Center for Imaging Research in 2005, and that led to the expansion of imaging faculty from 4 in those days to 25 today. We've invented MR fingerprinting. There are many imaging companies in the surround in Cleveland. It's really a hotbed for medical imaging technologies. And currently we have 25 faculty members with over $100 million of current research funding. Our graduates are leaders in academia, industry, and research centers around the world. And here's just a few. Ravinder Manjeshwar is Director of CT and Radionuclide Research at Philips Healthcare. Olivier Salvado is Head of Imaging and Computer Vision at a large clinical research group in Australia. Louis Solario, one of our more recent graduates, is now an assistant professor of biomedical engineering at Purdue. We actually have a wonderful facility at Case. This includes animal MRIs, micro-PETs, micro-SPECT, micro-CT, and so on. And this led one of our faculty members to call this the Disneyland of imaging. We're quite proud of our NIH-funded Imaging T32 training grant. This is a highly competitive grant to fund PhD students. It's in the 13th year of continuous funding. Our last submission received an extremely rare perfect 10 score. So this means that our colleagues around the country have decided that our program is perfect. So now I'm going to look at some focus areas in our group. One way to examine our faculty is to look at how they contribute to different diseases and conditions. We have several faculty that are involved in cancer, others in cardiovascular disease, neurodegenerative disease. We have a new entry into studying the effects of opioids. Some of us are looking at imaging the eye. And we have other faculty who are examining metabolic and gastrointestinal conditions. So looking at the imaging in this way, we can see that millions of lives are affected. Cardiovascular disease and cancer are the #1 and 2 causes of death. Another way to talk about our faculty is by the technologies that are being used. And so image analysis and learning systems, by learning systems I mean machine learning and deep learning. We have several faculty who are involved in that. And the students involved in these projects will create software programs with image processing and learning systems, design learning system experiments, that is, how do you do a deep learning experiment? And they'll typically work in multiple imaging modalities. And so the skill set will include machine and deep learning, statistics, software, physics, experimental design, and biology. So another technology is MRI methods development. And we have several faculty who are involved in that. And there, students will program MR scanners, perform imaging experiments, develop computational methods for MR imaging, that is that MR fingerprinting I alluded to previously. And they'll be optimizing MRI methods for specific disease tasks. We have several faculty who are involved in molecular imaging. So molecular imaging means imaging molecular processes inside the body using the imaging technologies. So here students will create new targeted imaging agents visible with fluorescence, radionuclide, or MRI. They'll create new nanoparticles for both imaging and therapy. We actually have coined a word for that. It's called theranostic nanoparticles. And we have several faculty who are doing that. And students will perform imaging experiments to assess sensitivity and specificity of the targeting. So the skill set includes biology, chemistry, the imaging experiment, and physics. Other faculty are involved in radionuclide imaging. That is where we have radioactive drugs, basically. Their students will create highly sensitive, targeted imaging agents which can be sensed at very low concentrations in the body. That's the true advantage of this kind of radioactivity image. They will perform imaging experiments to assess the sensitivity and specificity of targeting, and they'll learn PET and SPECT imaging physics. So the skill sets here include biology, chemistry, imaging experiments, physics, parameter estimation, and so on. Several of us are involved in optical imaging technologies. Our students have created optical instruments. They've created new microscopes. They're performing imaging experiments, and they're assessing the developing heart cancer and neural connectome and so on. Ultrasound imaging is another modality. Their students will create ultrasound instrumentation, develop image processing methods to register images, improve visualization, and more, and use learning systems to analyze image data. Skill set, physics of sound, some instrumentation, some image processing and learning systems. There's always a need for knowledge of biology, and then the ability to do good imaging experiments. And finally, we have a group that's heavily involved in MRI instrumentation and optimization. And this is two of the professors that are involved in this, Drs. Brown and Martins, are from the physics department. And here students will simulate MR scanners, they'll model and build magnetic coils, perform imaging experiments, and optimize MRI methods for specific disease tasks. So we have a wonderful environment for imaging here at Case. Case Western Reserve University is closely linked to University Hospitals of Cleveland and the Cleveland Clinic. And both of these large hospital institutions are within easy walking distance of my office. And of course, we not only do we have collaborations there, we have national and global collaborations as well. There's involvement with clinical departments such as radiology, cardiology, ophthalmology, pathology, and so on. We have several centers and institutes who are involved, including the Case Comprehensive Cancer Center, the Harrington Heart and Vascular Institute, the Center of Computational Imaging and Personalized Diagnostics, Interactive Commons, and more. And so students have an opportunity to work closely with clinicians to solve important clinical problems. And they can also work closely with basic scientists to create good, biologically inspired solutions. In summary, Case imaging is very, very exciting. Non-BMEs are welcomed into our graduate program. Case Biomedical Imaging has a proud history which continues to this day with groundbreaking developments. And we have a large amount of external funding to support PhD students. So the next steps are apply to our graduate program in BME or in physics. Then you can contact individual faculty members, attend our open house. And then, of course, for general information, we've set up this email account. Okay, so here are some sites around Case Western. We call this area the University Circle area in Cleveland. And these are just some of my favorite nearby sites.